Hey guys, this is Santos, and this week we're going to be talking about Le Chatelier's principle. So, an analogy we could think about is a seesaw that is in balance. If we were to put extra weight on one side, now you have to add weight to the other side to regain balance again. And that's how we talk about equilibrium shifts. And Le Chatelier kind of helps explain how that works. Chemical reactions make the same sort of adjustments automatically, and Le Chatelier's principle will help us understand that. What exactly does Le Chatelier's principle really mean? Or what does he state? So it says any change that occurs in a system at a chemical equilibrium causes an adjustment in the concentration of reactants or products that reestablishes that equilibrium. So that really literally goes back to our seesaw here. And just remember that he's really talking about that shift of weight that we have to do in order for it to balance out again. So what exactly does equilibrium really mean? So this is when the rate of the forward reaction is equivalent to the rate of the reverse reaction. So just try to recall from the last video what rate of reaction really means. So let's take a look at shifts of equilibrium. So let's take a look at this example I have here. Okay, and this is a shipment container here. And think of what's happening here, right? So in order to meet the demands of the public, the warehouse has to ship out products to meet their demands. And if things are in high demand and stock is low, warehouse is going to produce overtime just to try to get the ship as many of that product possible over to the product store. And then shipment will eventually slow down, and they'll just continue going back and forth to make sure to meet that demand. And when we see that the amount of products we have in the product store, or the rate at what things are being sold is equivalent to the rate at which things are being made, that's what we can compare to an equilibrium. Okay, and I hope that helps with understanding equilibrium. But let's apply Le Chatelier's principle here, and I'll explain it with this reaction here. So this is a reaction that shows the formation of ammonia. And let's see what happens when you add these additional stresses to the system. So first of all, we're going to make believe this is in a closed system. Meaning if it was in an open system, gases could escape and you wouldn't be able to reverse things, right? But if it was in a closed system and we were to add nitrogen, think of a seesaw. We started off with a seesaw at equilibrium, and then we added stuff on this side, so then it just gets heavier, right? And in order for it to balance again, we have to shift our weight over to the other side in order for it to be balanced again. Okay? So think about that. So it's the same thing with what's happening in this equation, right? So when we're looking at this, we increase nitrogen, it's going to shift away from it. Okay? And it's going to favor our product side. And I'm going to write products here. This is reactants. Okay? So that means that the concentration increases on this side. So I'm going to write C for concentration. I erase that. You guys get the point though. But concentration is going to increase on this side. If we increase hydrogen, it's also going to shift away. And that means concentration on the left side of the arrow is decreasing while the concentration on the right side of the arrow. And one thing I want you guys to keep in mind, even though it's being favored going to the right, it doesn't mean that nothing is going towards the left. Things are going to the left. It's just that the rate at which ammonia is breaking down to give you nitrogen and hydrogen is a lot slower than the rate of what nitrogen is combining with hydrogen to make ammonia. Same thing with ammonia. If we increase ammonia, it's going to actually shift away and it's going to go towards the reactant side. If we remove nitrogen, it's going to shift towards it. Anytime you remove things, it's going to shift towards it. Same thing with hydrogen. If we remove ammonia, it's going to shift towards it. And heat also works the same way, and I'm going to write H over here because this is our heat energy. So if I increase temperature, so this side increases, it's going to shift away from the side that has the heat energy in. If I decrease temperature, it's going to go towards it. Okay, so let's take a look at a checkpoint. So first of all, let's look at the heat energy. So this is positive, meaning it's endothermic. So it's going to be on this side. So I'm going to write energy. You guys recall that, right? If it's endothermic, it would be on the reactant side. If it's exothermic, it would be on the product side, right? So it says, which way will the equilibrium shift if we add hydrogen? So if we add hydrogen, it's going to go away from it. So it's going to go to the left. If we remove oxygen, it's going to go towards it, right? So it's going to the right. And if we increase temperature, which is on the left side, it's going to go, the heated energy is on the left side, so it's going to go away from it. So it's going to go to the right. So let's take a look at this question here, okay? So this is which changes would cause the equilibrium to shift to the left. So if we add more oxygen, so this increases here, it's going to shift away. So it's going to go towards the right. And we want to go to the left. So if we add more of this, it's going to go towards the left, right? So this might be answer right here. If we add more of this, SO2, it's going to go to the right. This is going to go this way. And if we decrease temperature, it's going to go this way. So it's going to go to the right. So the answer here would be SO3. Which changes will cause a shift to the right? So if we remove oxygen, it's going to shift towards it. So it's actually going to the left. So that won't be the answer. If we add more SO3, it's going to shift towards the left. It's going to go away from it. So left. If we increase temperature, it's going to shift away from it. So it's also going to go left. But if we decrease temperature, it's going to go towards it. So it's going to go towards the right. So the answer would be D for that one. Let's take a look at this one. Okay, so this one is talking about phosphoryl chloride. Okay, so that's this one right here. So phosphoryl chloride, and it's giving you PCl3. And we want to know what happens when you add oxygen to the system. So if I add oxygen to the system, my equilibrium is going to shift towards the left. So I'm going to write L, and that's the reactant side. And the concentration of, so this is when we look at concentration. So we could say the concentration of, I'm going to just write P, I'm just going to write the L, the equation here. So POCl3 is going to increase. And you can also bring this right here and say the concentration of my products is going to decrease, okay? Because everything is shifting towards the left or towards the reactants. So that means my products are being used up to make more reactants so they can make that balance, okay? So that's why this is decreasing. And because our equilibrium is shifting towards reactants, that means everything on the reactant side is increasing, which also includes temperature. Let's take a look at the last one. So this one is talking about gases, okay? And with gases, I didn't talk about them earlier, but with gases, when we increase pressure of a system, our shift of the reaction is going to be towards the side with the fewer moles. And if we decrease pressure, it's going to go to the side with the most moles. And we're talking about gases, most mole gases of pressure. So when you increase it, it's going to go towards the side with So if you increase the pressure, it's going to go to sides with the less moles. If you decrease it, it's going to go to the side with the most moles. Okay? And this is only for gases. Okay? So nitrogen has 1 mole of gas plus 3. So that's 4 moles, and this one has 2. So you want to know formation of ammonia, which is NH3. So you want it to go this way. If we increase pressure, it's going to go to the side with the least moles. So that works because it's going to form ammonia. If you decrease pressure, it's actually going to go this way, right? So that's not going to work. If you remove nitrogen or hydrogen, that's not going to work because it's going to shift it towards it. So that's how we know the answer is A. I hope you guys are able to now understand the Chatelier's principle. And if you have any questions, just let me know. Have a great day.